Hi, so this video tutorial on circle geometry is about alternate segment. I'm going to teach you how to answer questions that includes alternate segment. So our theorem is if a straight line touches a circle and from point of contact a chord is drawn, the angles which the chord makes with the tangent are equal to the angles in the alternate segments. So we say that if a straight line touches a circle like this line we can name it TAB, and it's touching a circle at one point. So this straight line is a tangent, and from point of contact a chord is drawn. This is a chord A, as it is a chord, right? The angles which the chord makes with the tangent, this is the angle that the chord makes with the tangent. This angle we can name it X, and this angle we can name it Y, are equal to the angles in the alternate segment. So it just means that angle X is equal to angles in this segment, and angle Y is equal to angles in this segment. So if we draw up an angle in the major segment like this angle, this angle that we are drawing up, this angle, this point we can name it P. So this angle SPA, this angle we can call it X1, is equal to angle SAB, because of the alternate segment rule. That is, angles in this segment are equal to angles in this segment. So X is equal to X1. So that is all that the theorem means. So we can also draw up another angle, this angle. This point we can name it X, and angle this X2. It also means that angle SXA is equal to angle SAB because of the alternate segment rule. So X is equal to X2. So that is all that the alternate segment theorem means. And now let us work out examples. Example 1. Name two angles equal to AYZ given this diagram. Okay, which one is AYZ? This is AYZ, this angle. So the trick is the angles should be in the alternate segment. This is the alternate segment, this whole area. And the angles should begin with AY, the 2 points on the chord. There's 2 points on the chord. So these two angles, which are the angles that are equal to angle AYZ? This is equal to angles that start from here, angle ABY. This is equal to angle ABY. So angle ABY is equal to angle AYZ. And also, which other angle starts from here and ends the angle ACY, which is equal to angle ACY. So these are the two angles that are equal to AYZ. Part B, name two angles equal to CYX. So angle equal to CYX. CYX is equal to, this is CYX. So the angles should be in this segment, and they should start with C and end with Y. So this should be angle CBY, angle CBY. It starts here and ends here. And also angle CAY, angle CAY. So these are the two angles equal to angle CYX. Now for part C, name any angle equal to BYZ. BYZ is equal to, which one is BYZ? BYZ. So they should be in this angle, and it should start with B and end with Y. It will be angle BCY, this angle. So angle BCY is equal to angle BYZ. Now for part D, name any angle equal to BYX. BYX, so BYX. The angle should be in this segment and start with B and end with Y. So it will be angle BAY, this angle. So it's angle BAY. That is the angle that is equal to angle BYX. Now let us proceed to example number 2. Example 2, we are given this diagram. PQX is a tangent to the circle QRS. So this is PQX, the tangent to this circle QRS. Calculate SQX. This is SQX, this angle. And from the alternate segment theorem, we said that this angle XQX is equal to angles in this segment. So it is equal to angle SRQ, this angle SRQ. So to calculate angle SRQ, it is an angle in a triangle. So angle SRQ is equal to 180 minus 55 plus 48. Why? Because of the sum of angles in a triangle. Angles in triangle. So this is equal to 180 degrees. 180 degrees minus 103 degrees, which is equal to 77 degrees. From the alternate segment theorem, we say that angle SQX should be equal to an angle that starts here and ends here. So it's equal to angle SRQ. It's equal to angle SRQ because of the alternate segment theorem. Alternate segment theorem. So SQX is equal to 77 degrees because SRQ is equal to 77 degrees. Now let us proceed to the exercise. May you please pause the video and carry out the exercise that is on the screen. Then check out the solution thereafter. We'll start with number 1. In Fig 3, this is Fig 3. TV is a tangent to the circle TVS. So TV, this is a tangent to this circle. If SVT is equal to SVT is equal to 48 degrees and VS is equal to ST, VS is equal to ST. So this is an isosceles triangle. What is VTY? VTY. And from the alternate segment theorem, we say that angle VTY is equal to this angle VST is equal to angle VST because of the alternate segment theorem. As VCST is in the alternate segment and it starts at here and ends at here like this. So the first thing that we do, we can calculate angle VST. Since this is an isosceles triangle, these two sides are equal. We can calculate VST as VST is equal to 180 minus 2 times 48 degrees like this. So this is equal to 180 degrees minus 96 degrees. Why? Because of the isosceles triangle. This will be equal to 84 degrees. So our VST is 84 degrees, and we already said that VTY is equal to VST. So VTY is equal to 84 degrees. We have solved question number 1. Now let us proceed to question number 2. Number 2, in Fig 4, this is Fig 4. TS is a tangent to a circle PQRS. So this is circle PQRS. If PR is equal to PS, that is PR is equal to PS, and PQR is equal to 117 degrees, this is PQR is equal to 117 degrees, calculate RST, this is RST, this angle. And from the alternate segment theorem, we said RST is equal to an angle that starts from here and ends here, this is angle RPS, RPS. That is what the alternate segment theorem says. And we can see that PQRS is a cyclic quadrilateral. And opposite angles, these opposite angles add up to 180 degrees. That is, they are supplemented. So it means that to find angle PSR is equal to 180 degrees minus 117 degrees. That is what angles in cyclic, quadrilateral theorem says. So PSR will be equal to, what is PSR? It will be equal to 63 degrees after using the calculator. We now have angle PSR, and we can see that this side is equal to this side, so this is an isosceles triangle. So to find this angle, since this is 63, this will be 63 too. So to find angle RPS is equal to 180 degrees minus 63 times 2, 63 degrees times 2, because of the isosceles triangle theorem. So this will be equal to 180 degrees minus 126 degrees. So this will be equal to 54 degrees. We now have angle RPS, and we already said that angle RST is equal to RPS. So our RST will be equal to 54 degrees. So we have solved question number 2 because of the alternate segment theorem. Thank you for watching my video. May you please subscribe to my YouTube channel, Free Tutorials ZW, for more video tutorials.